Hello, ECO311. Now we move on to Chapter 8, Multivariate Regression Analysis. We are going to do a lot of confidence interval hypothesis testing questions. And in particular, we are going to learn some new statistical analysis methods. So let's look at the outline. There will be lots of calculations for this chapter. Confidence interval on the variance of error terms, which we have done before in ECO242. So we will do it again, but the only difference is that we would deal with multivariate regression. Confidence interval of each regression parameter. Okay, again, we did it in ECO242, so we will do it again in ECO311. The only difference is that the interpretation part, you need to talk about the ceteris paribus condition. And then same old story for hypothesis testing, the t-test, two-sided, one-sided left tail, one-sided right tail. And once again, you need to talk about the ceteris paribus condition in step 5. And then the last few calculations are totally new for you. We want to conduct t-test hypothesis testing, this time on equality of two parameters, and we are going to focus on two slope parameters. So we want to know, are these two slope parameters the same or different in the PRF? And then finally, we are going to do 4 types of F-test, starting with the easiest one. F-test on joint significance of all explanatory variables. Second one, F-test on marginal contribution of additional explanatory variables. So in other words, we want to know if the regression improves after adding a few more additional explanatory variables. Restricted least square means if we impose some restriction on the slope parameters of the multivariate regression, is it going to improve or deteriorate the regression? Finally, structural stability child test. This is for time series regression only. We want to conduct an F-test to see if the slope parameter becomes completely different. For example, would it become steeper from a particular time onwards? Okay, we can't rely on graphical sketch only. We need to officially conduct the F-test. Okay, so the first one, confidence intervals of variance of error terms. So if you look at the study guide, I provide plenty of examples. So for these summary highlight lecture videos, I will only maybe do one question just to help you, to ensure you can fully refresh your memory or fully understand how to do this type of statistical analysis. So if we look at exercise 2, question 1, this is a multivariate regressions marked explained by study hours, party hours, sample size, K, degrees of freedom. Remember, I'm not supposed to tell you the degrees of freedom so explicitly. I think I can enlarge it a little bit further. Okay. Question 1.4, can you find out the 95% confidence interval of the variance of error terms? Interpret the answer. This is the formula. Remember, you don't need to memorize the formula. It appears in the formula sheet. And then we can do the substitution. N is 20. K is 3. You clearly see there are 3 parameters. And then this is the standard error of the regression, but you have to take square. So in other words, you have to take square of 2.6201. Okay, and now the trick is to find out the 2 chi-square statistics. Starting with the first one, degrees of freedom is 17, and then this is half of your alpha. Alpha is given as subtly given as 5%. You see 95% confidence interval. So it indirectly gives you a hint that alpha is 5%. So half of the alpha, degrees of freedom is 17. So let's look at the chi-square table. Half of the alpha, top row, 0.025, half of the alpha, 2.5%. Degrees of freedom 17, so this is our first chi-square statistic, 30.191. And then I substitute here. I think it should be fine with that. And then for my second chi-square statistic, still the same degrees of freedom 17, and then 1 minus half of the alpha. So it means 100% minus 2.5%. So it gives you 97.5% or 0.975. Degrees of freedom 17. This is why you get the second chi-square stat as 7.564. Okay, happy with that? Later we would use the t table. Okay, so 7.564, and then this is how you derive the confidence interval, and then you can do a little bit of interpretation. So let me stop for 15 seconds to see if you can understand the interpretation. All right, okay. Then we can move on to the next one. Confidence interval of each regression parameter. So let's do maybe 1 or 2 questions. Same old story as I mentioned right at the beginning. The only difference is the interpretation part. You must talk about ceteris paribus condition. And then still the same question, question 1, still the same information. So question 1.2, derive the 95% confidence interval of the true B2, so the slope parameter in connection with study hours, and interpret the answers. So we substitute the value. Maybe I should show you the equation actually. Okay, so let me copy this. Okay. Okay. So B2 head 6.1271 minus standard error of B2 head, which must be given to you 1.5779. The t-stat I'm going to show you later how I get 2.110, and then the right hand side it is the same story except the minus sign is changed to plus sign, and you must show 95%. 95%. So alpha is 5% split into 2 parts. Remember for confidence interval, we just like two-sided hypothesis testing. We split the alpha into 2 parts. So 2.5%. So top row of the t table, 2.5%. Second row, your full alpha, 5%. Degrees of freedom, 17. And this is how you get your t-stat, 2.110. Okay. Then we can go back to the answers, and then this is my confidence interval, 2.7977 and 9.4565. And then the trick is that for the interpretation, you must talk about ceteris paribus. So let's look at the interpretation. It means if 100 samples of size 20 are selected and 100 confidence intervals are constructed, we expect 95 of these confidence intervals will contain the true B2. And then for the above confidence interval, which is this one, if study hour increases by 1 unit, then the ceteris paribus condition, providing there is no change in your X3, your party hours on average, final mark would increase. You see the positive range here, or the positive confidence interval. So the final mark would increase by somewhere between 2.7977 and 9.4565 units or marks in the PRF. Okay, so let's do one more. This time the confidence interval on the other slope parameter, negative slope parameter. So be careful with the substitution. And you can see from the question, it gives you a subtle hint that I changed the alpha to 10% this time. So in other words, top row, half of the alpha, 5%. Second row, full alpha, 10%. And then degrees of freedom is 17. So for this one, my t-stat would be 1.740. Yep, indeed, 1.740. Then I can substitute the answers. Probability, B3 head minus 3.0041, and then minus standard error of B3 head, 1.5214 times the t-stat, which I have just found from the t-table. Then the right-hand side, same story, except the minus sign is changed to plus sign. Then as expected, you get a negative confidence interval because theoretically we know the negative or inverse relationship between study hours and between party hours and marks. Okay, and then this is the confidence interval, then the interpretation. So you spot the keywords increase and then decrease because of the negative relationship between party hours and marks. So let me stop for 15 seconds for you to go through the interpretation. Okay, then we move on to hypothesis testing. Then we will do question 3. So if you look at the slides, again, same old story. One-sided, two-sided test, except again for the 5th step interpretation, you must talk about the ceteris paribus condition. So let me undo these yellow highlights because we are using the T table again. So let's look at the information in question 3, multivariate regression. Sample size 33, K is 3, degrees of freedom 30. And again, I am not supposed to give you so much detail. You are supposed to find out the K and degrees of freedoms on your own. So I'm going to do only 2 questions here because I gave you plenty of examples when it comes to in-class exercises and the study guides. Okay, so first one. Currently, in the sample regression function, your B2 head is 5.3325, which is greater than 4 actually. So I want to know what is going to happen in the PRF. Would the true B2 be equal to 4 or greater than 4? You spot the keyword greater than, so it must be one-sided right tail test. Step 1, I think you should be fine with the null hypothesis and alternative hypothesis. Step 2, computer t-step, which is your B2 head, which is given 5.3325 minus the hypothesized true B2 value, which is 4, divided by standard error of B2 head, which must be given to you, 0.9884. Then this is your computer t-stat, 1.3481. Critical t-stat, alpha is 10%. Remember, one-sided test, I have got my full alpha in the top row. Degrees of freedom is 30. So this is my critical t-stat, 1.310. Okay, happy with that? Yeah. I'm not going to do the graphical sketch. I will leave it for you to do it now. You have enough experience on the graphical sketch. Since the computer t-stat is greater than the critical t-stat, we reject the null hypothesis. Then it means statistically speaking, the alternative hypothesis is more likely to happen. Then look at the interpretation. So H1 would take place, meaning if X2 study hour increases by 1 unit, providing there is no change in my X3 party hours, which means I'm talking about the ceteris paribus condition. On average, final mark would increase in the PRF, and such an increase would be greater than 4 units. Okay, then we can do one question on one-sided left tail test before we take a break and get ready for the F test. Okay. Currently in the sample regression function, my B3 head minus 2.0041 is smaller than minus 1. So I want to know would the same thing happen in the PRF. So null hypothesis, the true B3 equals minus 1. Alternative hypothesis, the true B3 is smaller than minus 1. So you see smaller than or less than. So it gives you a hint. It is one-sided left tail test. Computer t-stat, B3 head, which is given minus 2.0041 minus the hypothesized true B3 value. Remember, be careful with the substitution because now we substitute negative value. So minus 2.0041 minus bracket minus 1 divided by standard error of B3 head 0.5576. Then we derive the computer t-stat as minus 1.8008. Critical t-stat, alpha is 5%. Here, one-sided left tail test. This is why my critical t-stat is 1.697. And because this is one-sided left tail test, we have to add the negative sign. Then it becomes minus 1.697. And since the computer t-stat is smaller than critical t-stat, null hypothesis is rejected. So it means statistically, from a statistical point of view, the alternative hypothesis is more likely to happen. So can you read step 5 to see if you understand the interpretation? Okay, I think we are making good progress. I think we can take a break now. Oh, actually, there is one more type of t-test we have to do in the next table, which is about testing where the two slope parameters are equal to each other. And then the equation will be given to you. But remember, you have to read the question, which two parameters are of interest in the question. So if it is about B3 and B4, then this is how your equation looks like. And if it is about whether B2 equals B4, you just have to change these parameters a bit. Now you see B2 and B4. Okay.